Hello everyone. Now that we have looked at how to read and understand position graphs and information, we're going to take a look at how to actually calculate some quantities from that information. So first we're going to define and make sure we know what we're talking about. Displacement is just a word for your change in position, okay? And so we call that delta x. Change in anything is just your final minus your initial. So you take your final position, you subtract it from your initial position, right? If today I have $30 in my wallet and tomorrow I've got $20 in my wallet, I know I've lost $10 because I have $20 and I started with 30. So you just do 20 minus 30. Same thing with position. You just take your final minus initial. If you end at 10 meters and started at 2, you've moved 8 meters. Your distance traveled is actually how far the object moves from its point of view, okay? So you add up each segment of motion. You've got to remember, distance does not have a direction, and so it's always positive. So if you move backwards 8 meters, you treat it as positive 8 meters, okay? So if you move forward, you go forward 8 meters, you go backwards 6 meters, and you go forward 2 meters, okay? To find your distance traveled, you just add up all of those. 8 plus 6 plus 2 meters, meters, meters. I'll give you 16 meters, okay? In reality, you'll find out you really only moved forward 4 meters, but the object has moved that far. Instantaneous velocity, well, our velocity is equal to our change in position over our change in time, which we know is just our slope on the graph. So if you want to find your instantaneous velocity, you just find the slope on the position graph at the given time. And lastly, the one we're going to look at today is average velocity. So that's kind of like your overall velocity. Okay? If you had traveled at one constant velocity to get from your first point to the second point, how fast would it have been? So you find your average velocity by taking your total displacement over your total time. We will take a look at what that looks like here in a second. And so those are the 4 quantities we're going to take a look at. Let's do some examples and see how that plays out. So here we go. We've got a position graph. Let's take a look at what it shows us before we even start our math, okay? And so we start here at negative 4 meters. We move forward at a constant rate until we get to 1 meter, where we stop. For 2 seconds, we are at 1 meter, okay? So that means we've got 0 velocity. And then we go backwards to end up at negative 1. So if our displacement is equal to our final, or our total, our final position minus our initial position, we go here and make sure you keep these signs because it makes a difference if you include that negative or not. So your final position here is negative 1 meter. You're going to subtract your initial position, which is negative 4 meters. And negative 1 minus negative 4, so negative 1 plus 4 gives you 3 meters. Okay, and as we can see here, you just go over here, we've moved up 1, 2, 3 meters. We've moved forward 3 meters. The distance traveled, however, and do a little more work here. So distance traveled, the first step we said we move forward from negative 4 to 1. Okay, and so we can count the lines. You can do 1 minus negative 4. So we know the first one, we travel 5 meters forward. We then stay stationary for 2 seconds, so we don't move anywhere. So that's 0 meters. And then lastly, we go from 1 here to negative 1 here. And so we can find negative 1 minus 1 gives us negative 2 meters. But because distance doesn't have direction, we just move another 2 meters. And that tells us that throughout these 3 segments of motion, the object has moved 7 meters, okay? But if you look at the initial position, close your eyes for 6 seconds and then open it again, it looks like they've only moved 3 meters, but the actual object has moved 7. Okay? Now, instantaneous velocity at 1 second, okay? So right here, we're looking at 1 second. Don't find the point here, okay? That's position. So at 1 second, we're right above negative 2 meters. That does not tell me anything about my velocity. My velocity is going to be my slope, okay? So if I want to find my slope, your velocity is going to equal your final velocity position, eraser, is going to equal your final position minus your initial position over your final time minus your initial time. Okay? Just find the slope of that line here. And now it's not final at 6 seconds, it's final for that straight line here. And so I'm going to use this point here and our initial point here because it crosses on an XY marker. And so we've got our final position of 1 meter. We've got our initial position of -4 meters. Our final time here is 2 seconds, and our initial time is 0 seconds. So 1 minus -4 gives us 5 meters over 2 seconds, which will equal 2.5 meters per second. Okay, and so my velocity for these first 2 seconds, okay, if I ask you the velocity at 0.5 seconds, 1.5 seconds, it's all the same because it's a straight line, so that velocity is not changing. Okay. And then, like we said, our average velocity is just our overall. So we found our overall displacement here. So we've got 3 meters, and our overall time is here at 6 seconds. So that gives us our average velocity of 0.5 meters per second. So what that means is if I wanted to travel at one constant velocity from the initial point to the final point, I would go forward at 0.5 meters per second and end up at the same spot. Okay? Now, there's another way we can do this. Okay, we're given information here. You can either get the information from the question and do it, or graph it. I always find it easier to graph. Okay, so the first one is they travel forward at 10 meters per second for 3 seconds. Then they move back at 8 meters per second for 4 seconds. And lastly, it kicked forward again at 12 meters per second for 3 seconds. So we get to graph this. We're going to use displacement is equal to velocity times time because it is constant velocity. And so the first step, 10 meters per second for 3 seconds. At 3 seconds, we will be at 30. Then it kicks backward at 8 meters per second for 4 seconds. 8 meters per second times 4 seconds gives us 32. So at 4 seconds after 3 gives us 7 seconds. We will move back 32 meters at -2. And then they kicked forward at 12 meters per second for 3 seconds. 12 meters per second times 3 seconds gives us 36 meters. 36 meters plus our -2 gives us 34 at 10 seconds here. We're going to connect our lines. Start at 0, 0, line, line. Sorry, I assume that is connected. OneNote does not like making lines. Okay. So our displacement. Final position is, we found 34 meters. Minus our initial position of 0 meters, we end up 34 meters ahead of where we started. 34. Distance traveled. So we add up each one of those segments we just found. So the first one we found was 30 meters. We traveled backwards 32 meters, but distance does not have a negative sign. We traveled forward 36 meters, okay? 30 plus 32 plus 36 will give us 98 meters. So even though we only ended up 34 meters ahead, going forward and back and forward, we ended up moving 98 meters. Instantaneous velocity here is pretty easy to find because it's given to us, right? You just look back at the equation. You can find the slope of your line you made, or you say, hey, wow, at the first 3 seconds, I'm traveling at 10 meters per second. And then lastly, average velocity. Again, we're just doing displacement divided by time. And so we found our displacement to be 34 meters. And our time here, we ended at 10 seconds. 10 seconds. Our average velocity is 3.4 meters per second. Okay. Always just make sure you know which graph you're looking at. If you're using a position graph, these are the main things you're ever going to be looking for. Just follow those steps. As always, you'll get the right answer, hopefully. So I wish you good luck. Have fun. Take it easy.